My name is Karine Pistilli, and I'm a computer engineer student from Brazil, and also a Google Summer of Code student for the second time with the Liquid Galaxy organization. My project this year is called HAS, and it is an Android app developed using Flutter to help on reforestation projects. With the collaboration of our partners Drone Korea, this app will be used to prepare reforestation projects by allowing users to register the areas, soil metrics, species information, and much more. As for the Liquid Galaxy cluster, it will be used to display all the information about the project area in a very immersive and easy to understand way. For this app, I chose to make an Android app due to a few reasons. First, because an app would be more helpful for the people working on the reforestation project, and sometimes they are on the field and can have only a cell phone. And it's also very easy to publish in Play Store and reach billions of users. Second, because Android is an open source, and all the idea for us in the Liquid Galaxy organization and Google Summer of Code is to support and create software that can be used and developed by anyone, completely open source. And last but not least, because I have experience with a framework, which is also open source and created by Google. It's called Flutter. Flutter is a framework for cross-platform developing, so you can create apps for Android, iOS, and web. I'm using only for the Android part, but I really like how everything is structured, with the language Dart, the available widgets, and the package from PubDev. Flutter allows for very fast development due to the organization of the widget tree, the Dart language, and also the way it compiles the code. So that was for me the best shot for this project, as I wanted to go with Android, but also be able to create a good quality and reliable and fast, and do it fast for the Google Summer of Code 2021. Hello, my name is Karine. I'm a computer engineer student from Brazil, and this is my second Summer of Code internship. This year, my project is the Reforestation Assistant Simulator. The purpose of the project is having an app for monitoring and carrying out reforestation projects in degraded areas, using drones or manually. With the metrics of each species, soil, and area, it's possible to follow the evolution of the reforested area. Integrated with Google Earth, we can display the areas clearly and dynamically using the power of the KML language and also Liquid Galaxy. On the current stage of the app, users can register seeds and use them on reforestation projects, defining the metrics of the area, soil, weather, and also working with Google Maps to mark the seed places and also the complete area. Users can also see their project, edit, delete, and launch them to be displayed on Liquid Galaxy. The next steps for the project is to implement custom seed selection markers on Google Maps and Earth, improve KML style, implement translations with both English and Spanish, create graphical information to display metrics such as CO2 capture, for example, integration with Google Drive, and other details that were still not finished on this first period of coding. Now, let me show you a little bit of the current status of the app. So first we have the splash screen that has all of our partners, including Drone Korea, which is our biggest partner, as their group is going to be using the Reforestation app first. The first page, we have all the projects we created for the reforestation. Some of them are mock data that were created by the Liquid Galaxy Lab students. If we click on a project, we can see a summary of it and also be able to edit, delete, and also launch to Liquid Galaxy. Download and map buttons will be implemented later for downloading the information and also to show the map without needing to edit. If we hit launch, our project will be starting on Liquid Galaxy and will be display a polygon and to represent the area and also the markers where the seeds will be put. If we hit edit, we go to the project form, where we can change the basic information, also add information about the sewing window time, add all the speeches that we're going to be using on this project, including the density of each of them. We can define the area by the help of Google Maps. So we draw on Google Maps and that displays on Google Earth. And we can also put the area attributes and the soil attributes. So back on the first page, we also have to register the seeds. So here we have a list of mock data seeds where we have all the information for them, like the common name, scientific name, CO2 capture per year, and so on. We can also edit and delete a seed. So if we hit edit, for example, we have all the information. With the upload file option, we can choose a different icon for this seed that will be implemented later on the next coding period. And last but not least, we have the configuration screen. That is where we do the connection with Liquid Galaxy. We put the IP address and the password, and we hit connect to start the first connection with Liquid Galaxy. Pages like the About, for example, will be done later with information about all of our partners and our project. So, thank you for watching.
Hello, my name is Otávio. I am a computer engineering student at my third year of college at Facens, Sorocaba, a Brazilian university. And I've been developing Android applications since the start of 2020. And my main programming language for that is Flutter. I use it because of all the great UI components that come with the framework and an awesome collection of packages developed by the community. All of my work developing for the platform was very satisfactory, both for the huge number of people developing for Android, constantly helping the community, as much as for Google as a company for delivering a great experience for publishing apps at the Play Store. For this year of Google Summer of Code, I decided to develop an Android application, mainly because it's the platform that I feel more comfortable writing code, and also for some mentors and students of the organization that developed or are developing for Android, so we can help each other every time someone needs. I believe that developing for Android is to enter an amazing community and helping the open source world. Thank you. Bye bye. See you next time.
Hello, my name is Otávio. I am a third year computer engineering student at Facens, and my project for this year of Google Summer of Code is the image satellite visualizer. The main idea of the project is to have an Android application which I can retrieve imagery from space agencies like NASA and Copernicus. And after that, these images that I can edit with filters, I can send it to Liquid Galaxy to have a visualization like that. The first screen of my application is a dashboard. Here you can see all the images that you saved, and you can also press the plus button to create a new image. In this first step, you can select the API that you want to use. In this example, I'm going to use the NASA API. Here you can select the data of the image that you want to query. So you can press the get locations, and the Google Maps opens for you. When you click this square button on the top right of the tablet, you can select points that you want to use for your application. You can press the reset button if you want to get something else. In this example, I'm going to go to Tibet. and get this region. I can get the date of the image that I want to query. The next step, I'm going to select which layer that I want to query. For example, I'm going to use the character reflectance, true color. And here you can see a preview of the image to be saved and some information that you use to save the data. For example, I'm going to use Tibet as a name and copy some info that I searched on Google. And after that, the image that I queried is saved on the device and showed on the dashboard. If you want, you can delete it. You can see that I have a demo button and a Wi-Fi button. The Wi-Fi button is going to connect with the Liquid Galaxy, and for the next step, I'm going to send these images from the device to a Liquid Galaxy with this arrow button. Thank you for watching, and I hope you like my project.
Hello everyone, this is Gautam Verma here from Indore, India, and I'm currently pursuing Master of Technology from GDG Lleida University in IT. I'm a second year student and passionate about Android development, and I'm also an open source enthusiast. As for this year GSOC 2020, I got a chance to work with the Liquid Galaxy community, and I prefer to code in Android platform because I believe that this platform really allows new features and options to, not only for user but also for a developer. So I prefer this platform to do my coding stuff in this. And as for this year, I have planned to implement new features in Simple CMS. And Simple CMS is an Android application which was developed in GSOC 2020 by my mentor Diego, and as we know that we are working for an open source organization, so these things allow me to reuse the code of Simple CMS easily without any hesitation or without any intellectual property. I easily use the code of Simple CMS from the things are all the stuffs are available on the GitHub. I make a fork of it and implement a new features in it. I want to tell you something about my new features. I have implemented the export ESP button in Simple CMS. Export ESP button is the things we can do with the APK. We have created the storyboard of the locations, and then we can easily export in the ESP format, and we can import it on Google Earth Studio. Google Earth Studio is a software which create an animation for a location in different views, spiral, orbit, zoom to features. I have implemented all these features in Simple CMS. We just need to choose the features, and we need to click on the export. If we click on export, the whole storyboard content goes to export to the other application from which we want, and Gmail and whatever we want to export. And we all we need is import the export ESP in Google Earth Studio. That's fine. I would like to show you some of my code work in Simple CMS, so that it can become a more powerful and helpful that export ESP file. So here you can see that this is a screen of Simple CMS, and under this I've implemented two class export ESP class. As under the export ESP we have two class, export ESP and record. Under this export ESP you can see that I have implemented functions to calculate the value for longitude, latitude, and export in different position. In the record function you can see that we can record the particular location. And under the create storyboard I have implemented a function to export this whole contents storyboard in just one go. We just need to click on story the user wants to export the whole storyboard content. The user just click on export, then all the data will be going to be export easily. You can see that under the layout section I have implemented the button. You can see that at the left top corner, here, you can see that here, this is an export ESP button. and I have also implemented a record button under under these things. So I think that this is the update and version of simple CMS, which we can call a simple CMS e.s. Thank you so much for watching this video, and thank you so much. Hello everyone, this is Gautam Verma from Indore, India, and I'm currently pursuing my Masters of Technology from GDG Lleida University, a dual degree program in information technology, and I'm in second year, and I have created the project named Simple CMS e.s for Liquid Galaxy this summer in Google Summer of Code in 2021. Let's see what something about my project and how it's work. This is our APK screen, and I have already created the POI for the location. Here I enter the longitude, latitude, altitude, and the duration for the ESP file, and heading is set to a 0.0 and tilt is 3.1 and 0.0. Let me save this, and whenever I click on the export button, the pop-up menu will appear. It will ask for the feature we want to select. I have select like orbit. The pop-up menu, the pop-up appears, and it will ask you to select the APK from which you want to export the file. I will select the Gmail, and like here you can see that it is automatically attached the file for ESP file. Let me enter my just send the APK. We have like all three ESP files from all three features, like one for orbit, one for zoom to, one for ESP, and one for orbit view. Let me show you. You can see that here is py dot. I'm going to import our all three ESP file in Google Earth Studio. From import ESP file, like first let me import the orbit view file. Oh yeah, you can see that here it is orbit file, and here the longitude and latitude that we have entered in our simple CMS e.s APK. This is longitude, this is latitude. Okay, so let me run this. You can see that it runs perfectly and smoothly with 20 seconds video duration. Yep, it works perfectly. So let me quickly import some another file also, like for the spiral one, the longitude, the latitude, for 20-second videos. Like it sounds like whoa. This is spiral view. Okay, so let me import the zoom to file also. So it starts from 5,000 kilometer and goes to a little one, not zoomer, just by here.
Well, hello everyone, my name is Albert Morea Font, and now I will present you my project for the Google Summer of Code of this year. Well, the project is called Orbit Satellite Visualizer, and the main objective of the project is using an API that gets information from Celestrack. Okay, we are able to get information of any orbiting body around the Earth. And the main objective of the project is to display this information. There's a lot of different types of information using the Liquid Galaxy. Okay. For example, one thing that we can see is, for example, the International Space Station, the ISS. As we can see, we can observe its full orbit and also the height of around 500 kilometers. We have the orbit in white line, and then we have the ground track in red. This is the projection of the orbit over the Earth's surface. And then we also can have not just one orbiting body, but more. For example, a constellation of 5 Starlink satellites. You can see here, you can see each satellite with a different color in order to distinguish them. For example, here we can see one of these satellites with the ID 46795. Right now, all this information is stored locally. It's generated by the project, but it's not updated automatically. From now on, the next step of this project is to get all this information in real time, and I will try to display all the satellites in near real time.
Hola, buenas.
Buenos días.
¿Cómo estás?
Muy bien. ¿Tú?
Perfectamente. ¿Qué tal? Por aquí.
Aquí con los manzanos.
Ahora que estamos en un campo de manzanos, te voy a mostrar uno de los proyectos que hemos desarrollado en los laboratorios TIC del Parc Científic de Lleida, el Crop Dog Terminal.
Genial.
Déjame que te explique antes que el Crop Dog Terminal es la implementación en Edge y con 5G del proyecto Crop Dog, que es un modelo de inteligencia artificial especializado en la detección de enfermedades de las plantas. Utiliza una combinación de dos potentes sistemas hardware de ejecución de modelos de Machine Learning, uno basado en las TPU Coral de Google, procesadores especializados en sistemas de IA, y una Jetson Nano de NVIDIA, con una gran potencia de GPU. Ambas se complementan perfectamente, ya que una aporta la capacidad de lo que llamamos inferencia, ejecutar el modo en local, es decir, aplicar en la foto que captemos la IA, y la otra la del aprendizaje, donde entrenamos el modelo con más de 25.000 imágenes que hemos insertado con diferentes estatus de las plantas, desde enfermas hasta no enfermas y otros estados. Por cierto, cuando he dicho Edge, me refería a que esta tecnología lo que hace es acercar lo que normalmente tendríamos en la nube en un gran centro de proceso de datos a donde se usa, en este caso, el campo, acelerando la velocidad de proceso 100 veces respecto a un móvil. Aunque obviamente también contamos con la nube, donde la capacidad de proceso es aún mayor, y por eso nuestro terminal incorpora comunicaciones 5G, para poder transmitir a altísima velocidad cientos de fotografías que un agricultor o profesional agronómico pueda captar. Eso sí, el dispositivo también funciona en modo sin conexión, ya que no siempre se dispone de conectividad en los campos.
Hoy me estás haciendo un máster en inteligencia artificial.
Ya ves, y además te daré otro dato para acabar tu máster. En un futuro trabajaremos en lo que llamamos un modelo federado, gracias a la potencia de Google Cloud, donde diferentes agricultores que usen el sistema estarán enviando su modelo, que no las fotos, a la nube, de una forma automática, para hacerlo más inteligente, compartiéndose entre todos estos avances.
¿Y entonces se comparte la experiencia de todos?
Sí, y el agricultor, que tiene normalmente más experiencia de todos sus años en el campo, corrige el sistema cuando detecta un resultado incorrecto, y esto se comparte igualmente con todos los usuarios.
De acuerdo, ¿y entonces qué tengo que hacer?
Simplemente cógelo y apunta con la cámara a una de las hojas y hazle una foto. Como puede ver en la pantalla, este árbol ahora mismo está sano. En el caso de que padeciera alguna enfermedad, el software analizaría la foto y mostraría el porcentaje de la probabilidad de que la planta padeciera de dicha enfermedad.
¿Y esto funciona con todas las enfermedades?
El modelo de inteligencia artificial que hemos desarrollado sirve inicialmente para detectar una enfermedad de las plantas muy específica, el fuego bacteriano. En un futuro, esta misma plataforma podrá ejecutar otros modelos para otro tipo de enfermedades de las plantas. Imagínate, podrás detectar si el geranio de tu terraza está enfermo o si el maíz está sano. Es decir, podrá servir para muchos tipos de enfermedades siempre y cuando podamos aportar al modelo suficiente cantidad de imágenes para que aprenda.
Genial. Hasta luego y suerte con el proyecto.
Muchas gracias.
Hello, I'm Paula Marin, a 22-year-old student at INSA Toulouse in France, and this summer I participate in Google Summer of Code. I am developing an application called Sandbox Data Viewer for Rocket Galaxy. This application will get data from Sandbox API, which is an open source international ground station network, and the application will use this information to plot satellite information in Liquid Galaxy. So, in fact, this application will be used to show in Liquid Galaxy a satellite in its orbit and a balloon next to the satellite showing the name and data collected from that satellite from Sandbox database. For that, I am using Android Studio to develop the application that will be used in a tablet, where we can choose different satellites to plot. For the moment, I'm developing all the code in Python as it's easier for me, and for the next step, I will try to pass all the code from Python to Java. For the moment, I'm able to communicate with the Sandbox database, get the data, and plot a balloon next to the satellite in the orbit. The satellite, for the moment, it's not displayed, but I can display a balloon in the orbit. As I cannot connect with a Liquid Galaxy device for the moment, I'm just testing my application with the Google Earth software. And now I'm going to show you one little demo of the result of my application.
Hi, my name is Leonardo and I'm a third-year computer engineering graduate from Brazil. My project for the Google Summer of Code 2021 is the Liquid Galaxy Retro Gaming, which consists in an app to manage the games on the Liquid Galaxy, as well as developing a new version of the classic Pac-Man game for the Liquid Galaxy. Here you can see the main screen for the app, which consists basically in a slider with the three main games, which you can navigate by either sliding or clicking the arrows to switch between the games. Whenever I click open game, the current game that is being displayed on the screen will open on all screens. Here you can see that I opened the Pong game. The controller is also opened here on the app. Whenever I click the back arrow, the game closes on all screens and I'm redirected to the main screen. Here you can see the same thing for the snake game, right? The game started and the controller opened. And for the Pac-Man open game, you can see that it opens on all screens. And here, if I just press start, you can see that the game starts. In the controller here, I have a current score, which updates in real time, and also a lives counter. And here you can see that I can already play the game. And here I just died twice. And here, if I pick up the power pill, you can see that I start going and killing the ghosts. I can go through the screens. And if I die here, you can see that I get a game over screen on the game, and also on the controller, which shows me the final score and a button where I can play again. So this is the current state of my project. My next steps would be to implement the multiplayer capacity for the game, so that I can have multiple Pac-Mans on the game, as well as making the ghosts actually played by real people and real players, so that we can have like a competition in the game. Thank you for watching, and I hope you liked my project.
Hello everyone, I'm dedicaremos. In 2020, I had the opportunity to participate in Google Summer of Code with Liquid Galaxy. This experience was amazing because I developed from scratch the application Simple CMS. I designed the UI and UX, focusing on having a smooth user experience. After this, I learned about the technologies used by Liquid Galaxy. In this time, I create different functionalities such as creating a tour with different actions as moving to a point, camera movements, add a balloon, and a shape. Save the tour locally or in Google Drive. And also, I add a tour from Barranquilla, Colombia, so you can check my city, where I was born. It was a long journey and a hard work, but at the end, I developed a nice product. Now, in 2021, I had the opportunity to be a mentor in Liquid Galaxy and teach the new students the technologies that develop Simple CMS, so they can go beyond and develop new functionalities. This made me proud because all these new students are using my code as a base and are developing new and great products for Liquid Galaxy. Thank you for your time.